All right, everyone. So we're going to look at a couple exam problems that are related to Newton's second law. So these questions I'm getting from the University of Florida, who they publish their Physics 1 exams from previous years, obviously. And I'm just going to go through and work through them. So that's where I'm getting them from. I'm starting at question 14 just because I'm skipping a lot of the projectile motion problems. We've already done those, so I'm probably going to just spend the next few days going over these types of problems and before moving on. So if you guys want to see the projectile motion problems, I can do those. Just let me know. So question 14, it says an elevator cab with a mass of 1200 kg moves downwards. What is the tension in the cable if the cable speed is decreasing at a rate of 2.2 meters per second squared? So let's start by drawing a picture, particularly a free body diagram picture. Now we know the cab is moving downwards, right? So we have our tension, we have our weight force, and we know it's moving down and it's decreasing. The acceleration is decreasing at a rate of 2.2 meters per second. So we know it's moving down. So if acceleration is decreasing, our acceleration is going to point up. So then we can do Newton's second law in the y direction. This is really just one-dimensional motion, but worth doing. Tension minus the weight force, which is mg, equals our acceleration is pointing up, so that's going to be positive. Tension equals mass times gravity plus acceleration. If you plug those in, you should get about 1.14 times 10 to the 4th newtons. Now 15 is the exact same problem. The only difference is now the speed is increasing. So if it's moving down and the speed is increasing, then acceleration is pointing down. So the only thing that changes here, I'm going to keep the free body diagram, is the sum of all forces in the y direction is equal to minus m times acceleration. So tension minus mg equals minus ma. Or tension equals mass times gravity minus our acceleration. And should you actually plug these numbers in, you should get about 9.12 times 10 to the 3rd newtons. Okay. Question 16, a little bit more to it. In fact, let's actually take question 16 and let's highlight that because I want to draw on it. Okay, so question 16 says 3 blocks of mass M1, M2, and M3 are pushed along a horizontal frictionless surface by a horizontal applied force, F, acting on M1 from the left as shown. The magnitude of the force of M1 on M2 is... So the first thing I'm going to do is I'm going to draw a free body diagram for each block individually, and then I'm going to go back and draw one for the system. So just looking at block 1, I'm going to color it black. We have a normal force, we have a weight force, we have this force applied, and there's also a force 2:1. So this is for block 1. Block 2, I'm going to do in green. It also has a normal force. It also has a weight force. And let's look at the forces touching on it. So we have the force of block 1 onto block 2, and the force of block 3 onto block 2. So this is 2. And it wants to know the force of M1 on M2. In other words, what we're looking for is this force. For the third one, what do we have? Well, we have a normal force, of course. We have weight. And we also have the force of 2 onto 3. It is a vector. You can draw arrows, but I haven't been doing it. So, oh well. You guys know what I mean. Well, I guess I did for my weights a couple times, but don't get too caught up on that. I was going to do it in a different color. Okay, well, I guess M3 is going to be green too. Now let's consider a system being M1, M2, and M3. So just imagine that all three of these were one block. Well, we would have a normal weight force, and ultimately this force applied. There's no friction, so we don't have to worry about that. So this is the system free body diagram. Okay? Now, let's see if we can work through a few things. First off, let's look at the system. Oh, it just kicked me off. Oh well, we'll get back on. Okay. So, let's see here. The sum of all forces in the x direction is equal to mass times acceleration in the x direction. This means acceleration is equal to the sum of forces in the x direction for our system. Didn't I draw a free body diagram? I thought I did. Did I just lose it? Thought I had a free body diagram somewhere. Okay, well, I'll draw another one. Normal, weight, and our force F. So that's for the system. So the sum of forces in our x direction is F equals ma. It's technically acceleration in the x direction, but I'm just going to call it a because there's no acceleration in the y direction anyways. Okay, so let's talk about this m. It's the mass of the system. So the force equals m1 plus m2 plus m3. Now this acceleration is the acceleration of the system, but it's also the acceleration of 3, of 2, and of 1. Whatever block 1's accelerating by, that's going to be what block 2's accelerating by. And whatever block 2's accelerating by is going to be what block 3 accelerates by, which is just going to be the acceleration of the system. So this acceleration is pretty universal in this problem. And we see the force divided by m1 plus m2 plus m3. So this is our acceleration. It's kind of a bad block, but let's summarize this a little bit. So free body diagrams were what we started with, and then we found acceleration. Let me turn my light on here. There we go. So let's okay, so we found acceleration. Now what? Well, let's consider a few things. Let's consider what's happening to block 1. The sum of all forces, so for block 1, the sum of all forces in the x direction is equal to mass times, again, I'm just calling it A. So force minus the force of 2 onto 1 is mass, should make a note, this is mass 1 times acceleration. Now, let's first talk about this. Let's talk about F2 onto 1. We're going to need to remember Newton's third law, which just says your forces all come in pairs. So the force of 1 onto 2 is equal to minus the force of 2 onto 1. Let's box that. We really haven't had to use a whole lot of Newton's third law to solve a problem before. Well, now we're going to need to do that. So our force plus F1 onto 2 is equal to M1 times our acceleration. Or F1 onto 2, which is the force we're looking for, right? We want to find F1 onto 2, is M1A minus our force. Well, our force is just equal to, let me do that a little better. Let's make that, I don't know, blue. We know what our force is equal to, and we know what our acceleration is equal to. So F12 is equal to mass 1 times our acceleration. Let's just keep it acceleration for now, because what will end up happening is minus M1 plus M2 plus M3 times acceleration. Let's distribute our acceleration. And mass 1 times acceleration minus mass 1 times acceleration plus mass 2 times acceleration plus mass 3 times acceleration. You can see the masses, M1A cancels. So F1 onto 2 is equal to M2 plus M3 times our acceleration. But we know what our acceleration is. We found it at the top. So M2 plus M3 times F divided by M1 plus M2 plus M3. And there you go. We just described the force here. So that is F times M2 plus M3 divided by this one. Don't even worry about 2. So there you go. We did we did 3 problems. 2 were pretty related. I'll probably do 3 or 4 tomorrow as well. And I'm probably just going to keep doing this until we move on to momentum, energy, all that good stuff, which should be coming up soon. So hopefully that helped.